This is the first video in a series of class notes on polynomial functions. So to start with, let's look at the definition of a polynomial function. So if we have a function f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and let that continue until we get a 1x plus a 0, where a n minus 1, all the way to a 0 are simply real numbers. And n is an integer, which is greater than 0, then we say this is a polynomial function. Let's look at a quick example. An example of that might be y is equal to 7 x to the third minus 5x plus 8. In this case, n is 3. 7, 5, and 8 are all real numbers. So this is a polynomial function. So the key here is that there's powers, but the powers are always positive integers. And that's another way to say it, is that they're terms in which all of the powers are positive integers. So let's look at a couple of terms associated with the polynomial function. The first thing with the polynomial function is we talk about the degree of a polynomial. And the degree of a polynomial is simply defined as the highest power. So the degree is the highest power. So if we go back to our previous example, y is equal to 7x cubed minus 5x plus 8. The highest power is 3, so we say this is a polynomial of degree 3. Then we have things called coefficients. The coefficients are simply a n minus 1, all the way to a 0, right? You might say a1, these numbers here. So here the coefficients are 7, minus 5, and 8. 7 is the coefficient for the x3 term. Minus 5 is the coefficient for the x term. 8 is called the constant term. So sometimes you'll see books single out a0 and call that the constant term. And then we have something called the leading term, which becomes very important in determining the general shape of the polynomial. The leading term is basically the x with the highest power with the coefficient. So that's the leading term. So let's look at an example. Let's say you had g of x is equal to 12x to the fifth plus 3x cubed minus 2x squared plus 6x minus 12. This is a polynomial function. It has powers, but all the powers are positive integers. If it's written from the highest power to the lowest power, we say that it's written in standard form. And almost always in textbooks, you'll see them written in standard form. If you take the term with the highest power, that's called the leading term. In this case, the leading term is 12x to the fifth, and sometimes they'll talk about the leading coefficient. And the leading coefficient in this case would be 12, a positive 12. So let's look at a couple of examples of polynomial functions and ones that are not. Example would be f of x is equal to minus 18 x to the fourth plus 13x cubed plus 2x minus 6. If you notice, they're x to a power. In each case, though, the power is going to be a integer and a positive integer, so that is a polynomial function. As is this one. G of x is equal to 19, x to the third, plus 16x minus 18. Examples that are not, one example of the not would be y is equal to 1 over 1 plus x. Another, y is equal to 3 square root x plus 7 plus 9. Right? Let's see about why this isn't. Well, you have an x, but it's an x which is a negative exponent. Another example would be 3x to the minus 5 plus 2x squared plus 7. So what can disqualify something from being a polynomial function? Well, it could have an x in the denominator, it could have an x which has a negative power, it could have an x which is underneath the square root, or it could have an x which has an exponent which is a fraction. So all of those are examples of not polynomial functions, and these are polynomial functions. And if you look at the key to polynomial functions are that they have certain regularities about them. And in particular, the graphs of polynomial functions have certain regularities, and that's what we're going to look at next. So next we're going to look at graph of polynomial functions. And what you should be able to do now is determine whether or not a function is a polynomial function. These are all not. This is and this is. And you should also be able to distinguish whether or not it's what the leading term is or the leading coefficient, and what the degree is. In f of x, you have a degree of 4, and you have a leading term of minus 18. G of x, you have a degree. Remember, the degree is the highest power, so g of x, the highest power is 3, so the degree is 3. And the leading term is going to be 19x to the third. The different books do it a different way. The leading coefficient in this case would be minus 18. The leading term minus 18x to the fourth. In this case, the leading coefficient is a positive 19, and the leading term is 19x to the third. And the last thing you should be able to do is know some basic vocabulary. If the degree is small, then we have certain terms for it. If you have a degree of 1, we call that a linear function, and you can recognize those. Y is equal to, for example, 2/3 x minus 7. The highest power is 1, the degree is 1. It's a line, so it's a linear function. If it's a degree of 2, we call that a quadratic, and the graph is a parabola. Example is y is equal to 3x squared minus 18x plus 6. If the degree is 3 or 4, there's also terms for it. Sometimes we just say degree of 3, but also we call it a cubic function. Just like x to the third is x cubed. And 4, a rarer term, but we call that a quartic. Fairly rare term, though I have heard it before. So degree of 1 is linear, degree of 2 is quadratic, degree of 3 is cubic. Degree of 4, sometimes we call it degree of 4, sometimes we call it quartic. The degree of 0 is a special function called a constant function. An example of that would be y is equal to 7. If you notice, the 7 is the same as 7x to 0, so the degree is 0, and we call it a constant function. Anyway, that's the part 1 of polynomial functions.